My name is Fatima Zatawi.
My name is Ashley Jennings.
My name is Emmanuel Blunt, and today we're going to talk about stem cell research. Stem cells have two important characteristics that distinguish them from other types of cells. First, they are unspecialized cells that renew themselves for being long periods through cell division. The second is that under certain psychological or experimental conditions, they can be introduced to become cells with special functions such as beating cells of the heart muscle or insulin-producing cells of the pancreas. Scientists primarily work with two kinds of cells from animals and humans, embryonic stem cells and adult stem cells, which have different functions and characteristics that will be explained in this document.
What are the unique properties of stem cells? Stem cells differ from other kinds of cells in the body. All stem cells, regardless of their source, have three general properties. One, they are capable of dividing and renewing themselves for a long period of time They are unspecialized and they can rise to special cell types. Scientists are trying to understand two fundamental properties that relate to stem cells to their long-term self-renewing. One, why can embryonic stem cell proliferate for a year or more in a laboratory without differentiating, but most of adult stem cells cannot?
What are embryonic stem cells? What stages of early embryonic development are important for generating embryonic stem cells? Embryonic stem cells, as their name suggests, are derived from embryos. Specifically, embryonic stem cells are derived from embryos that are developed from eggs that have been fertilized in vitro in an in vitro fertilization clinic and then donated for a research purpose with informed consent from the donor. They are not derived from eggs fertilized in a woman's body. The embryos in which human embryonic stem cells are derived are typically 4 to 5 days old.
Famous incident is going to be the case of Christopher Reeve. So this was the actor that played Superman in all the Superman movies. So he was thrown from a horse and had a neck injury, and of course the nerve cells that were in the spinal cord excuse me, once nerve cells have matured, they don't grow anymore, so those damaged cells could not regenerate, so he was left paralyzed from the neck down. But by implanting embryonic stem cells into that area, you have the propensity, the likelihood to be able to regenerate healthy nerve tissue, so that injury could have possibly, if not completely, but been at least partially repaired. So there may have been some repair process there to help heal that injury. You have other types of injuries, any kind of nerve damage injury that results from some mechanical or traumatic injury, car wreck, falling off a house or something, extreme like that. But also in terms of some genetic injuries, you can put healthy tissue in, and then maybe the healthy tissue can overshadow the genetically mutated tissue, so that you can grow healthy tissue to repair some genetic abnormalities.
To the best of my knowledge now, we've done that successfully with bladder cells. They can be converted from the stem cell or non-differentiated cell into a bladder cell pretty easily. So we understand the environment, the chemicals necessary for that. But yeah, any tissues in need of replacement. Well, it would certainly be nice if, like you said, for example, if you had tissues that were damaged in an accident or degenerative nerve disease, and you needed a replacement of those tissues, and you could find a way to go back to these stem cells, which are undifferentiated. They haven't decided what they want to do in life, and through the right amount of chemical and environmental conditions cause them to grow into any other type of cell that's necessary. You can certainly look at replacing ones that are damaged in a human body with these that are grown outside of a human body.
Noted. You can cure some injuries, you can cure some diseases, you increase the longevity of the individual because of these diseased or damaged states that will increase the mortality of the individual, so you have a longer lifespan. At this point, there's no known risk to the recipient because there's not really too much known about any kind of allergic response that the recipient might have from the incoming cells. Definitely. I was very pleased to see that one of the first things that this new president did was to repeal the limitations on stem cell research that had been imposed by the previous presidential administration. So this unties the hands of scientists to be able to do research on different diseases and to possibly find some cures that we would not have been able to find before.
Is that research?
I'm completely for it.
All right. Thank you.
You're welcome.
Personally, I think if the cells are collected in a manner that isn't going to really cause people to start going down the path of selling fetuses and things of that nature, then I have no problem with it whatsoever.